Okay, so this is problem 4 from homework 2. So this is the problem with the apple farm, and we're told that based on the size of the farm S in square meters, the number of apples produced is given by the formula 100 S squared. So in part A, we're asked to explain what's the meaning of A of 10. Well, A is just the number of apples produced by a farm of the given size. So if S is 10, that means that A of 10 is the number of apples produced by a 10 meter squared farm. Okay, so then in part B, we're asked to find A prime of S using the definition of derivative. So we have to look at the limit as h goes to 0, A of S plus h minus A of S divided by h. If we plug S plus h into our equation, we'll get the limit as h goes to 0, A of S plus h squared minus, I forgot a 100, no, I still have, okay, I put this A here, right? If I plug S plus h into A, then I get S plus h squared times 100 minus 100 S squared divided by h. Then we have this square here. We can simplify things by expanding the square. We'll get the limit as h goes to 0. I can factor 100 out of everything, and then I'll have s squared plus 2sh plus h squared minus s squared divided by h. The plus s squared and minus s squared will cancel. Then there's an h left over in all the remaining terms. We can cancel that and get that this equals the limit as h goes to 0 of 100 times 2s plus h, and this limit is equal to 200s. So then C asks us to use this to find A prime of 10, so we just have to plug in S equals 10, which gives us 2,000 apples per meter squared. Then part D asks us to explain in words what this means. So there are a few different ways you could say this, but one way you might say is that when the farm is 10 meters squared in size, it will produce 2,000 more apples for each additional meter squared added to the farm. And it's important, since remember the derivative gives you an instantaneous rate of change, it's important that you have this first part of when the farm is this size. So you're not saying that it's always going to be the case that adding this extra meter squared will produce 2,000 more apples. You're saying at this instant, when it was this size, that was the rate at which increasing the size of the farm would increase the yield. Okay, and then the next one asks us to predict the value of A of 11 using A of 10 and A prime of 10. So based on this statement in words, you can guess what the prediction will look like. So A of 11 is going to be approximated by the amount that we had when it was 10 meters squared plus the change at that size. And based on our calculations above, this will turn out to be, let's see, 10,000 plus 2,000, which is equal to 12,000 apples. And we can compare this to the actual value of A of 11 gotten by plugging into this equation. So let's say 11 squared is 121, so then we multiply that by 100. We get 12,100 apples. So we see that the prediction was a little bit off because this rate of change was not constant between s equals 10 and s equals 11. So based on the fact that we ended up higher, probably this function is concave up, which in fact it is because it's just a quadratic. And that's why we ended up with a higher value than the derivative predicted. So if you were to plot something, a of s, and at 10, the predicted value from the derivative is the value that the tangent line takes at 11, and the actual value is slightly higher, as can be seen from this graph.